Hey, thank you for joining me on this short little lesson on types of chemical reaction. So we've studied chemical reactions and we've looked at balancing chemical equations. We understand that in a chemical reaction, we don't create new atoms, and this was the law of conservation of mass, whereas every atom that we have in the reactants, they're still found exact same atoms in the same number in the products. So what we understand from that is that a chemical reaction is just a rearrangement of atoms. So they exist in a certain arrangement, and then we force them or we help them recombine or just rearrange and form something else. The thing that's very helpful for us is that in chemistry, these chemical reactions, they follow certain predictable patterns. And so if we know what the patterns are and we know what we start with, then we can predict what will come out of a chemical reaction. So we kind of anticipate, the products of the reaction. We don't have to just go by trial and error, but there's an actual method to these rearrangement of atoms. And that's what we're going to talk about today. We're going to talk about five different types of chemical reactions. We're going to study four main patterns, and then we're going to look at a combustion reaction, which is something that we use pretty much every day. So, as I've just explained or just reviewed with you, during chemical reactions, the atoms, they do not appear or disappear. Right? They don't come out of nowhere and they don't just vanish. So, and this was the law of conservation of mass, and we studied this a little while back. So chemical reactions is only a rearrangement of atoms. Whatever you have at the beginning, you're still going to have at the end. So there's four types of chemical reactions that we're going to look at today. Most common: synthesis, decomposition, single replacement reaction, and the double replacement reaction. So those are the four types of chemical reactions that we're going to talk about. And they each have, as you can see there on the slide, you each have a specific pattern. The last one, the fifth one, is a combustion reaction, and we're going to look at that simply because it's just all around us practically daily, and it's just kind of a neat reaction. Combustion, of course, is just another word for burning. So let's look at these four types of chemical reaction, each one a little bit more in detail, right? So the first one is the synthesis. So a synthesis is kind of, well, what the name implies, you're making something, right? A synthesis, a production, making. And so this is what happens when two elements combine together to form a product. And to do that, you use this simple pattern: A plus B gives AB, or the little red circle and the blue square, and then they combine together. So the synthesis is a type of chemical reaction in which two or more substances combine to form one compound. So there's only one product. You can recognize a synthesis because two or more reactants form one product. So a synthesis is, if you have a chemical reaction and there's two elements to begin with, there's only one thing that can happen, is these two elements are going to combine together. So if you see a chemical reaction and you look at the reactants and there's just two elements there, then you know it's a synthesis. The second type is decomposition. Well, again, like the name implies, it's what something is decomposing, is breaking down. Right? So this is when you have one compound and it separates into two smaller pieces. So that's a decomposition reaction. Now, if you look at the diagram here, you see it's exactly the same as a synthesis, only backwards. So in the synthesis, you take two elements and you combine them into a product. In the decomposition, you take this product and you separate it into your two elements. So in a decomposition reaction, one compound breaks down and forms two more substances. You can always recognize a decomposition reaction because there's only one reactant. So if you start a chemical reaction with only one substance, there's only one thing that can happen: is the substance is going to break apart. So the decomposition is a reverse of the synthesis. It's a reaction that goes in the opposite direction. Single replacement. Well, so this is a replacement. So this is a chemical reaction where you have a single element that comes in and it takes the place of an element that's already paired up. It's already bonded with another element. So it comes in, it swoops in, and it takes its place. So it replaces the element that's there already. So when a single element takes the place of another element, right, that's already in a compound. So this is called sometimes a substitution reaction. So if you think about it, it's exactly like, it's easy to think of a sport analogy where one player comes in and replaces another. So the coach calls for a substitution. Well, this is exactly what's happening here. So we can see that in a single replacement reaction, one element replaces another element in the compound. Now, what you have to be careful about here is that if your element that's doing the replacing, the single element, if this element is a metal, then it will replace the metal. If the single element is a non-metal, then it will replace the non-metal. So remember, in a compound, the metal always comes first and is followed by the non-metal. On the periodic table, remember the staircase-looking steps that separates the metals. The vast majority of the elements, right, would be metals, and there's a small section of the non-metals. So if your single is a metal, it replaces the metal. If your single is a non-metal, it replaces the non-metal. And look at the examples that you have on the slide here. You'll see in the first example, we have a metal, which is iron, and so when it comes in, it replaces the copper, which is also a metal. Right? In a double replacement, well, it's when you have two compounds and the elements in the switch partners. Right? So you have, when you start out with two compounds, so this is how you recognize a double replacement, is you're starting with two compounds. So if you start with two compounds, the metal of one compound takes the place of the metal in the other compound. So it's like a double, it's like a switch. So the double replacement reaction is like when two elements switch places. So in a double replacement reaction, the negative ion, that would be the non-metal, right? In the two compounds, they switch places. It's also the same as if you say, well, the positive ions are going to switch places, right? So the positive switches with the positive, or which is metal with metal, or negative with negative, which is non-metal with non-metal. So in this example here that you see, you have the NaCl and you have AgNO3. Well, so Na, the metal, is going to take the place of the Ag, the other metal. So Na swaps with Ag, and Ag takes the place of Na. So those are the main four types of chemical reactions that we need to be familiar with. The combustion reaction, which is the fifth, is burning. Right? So when something burns, combustion, is very easy to recognize because you're always looking for oxygen in the reactants. Right? A fire needs oxygen, and it produces carbon dioxide and water. So on the one side, as a reactant, you always have oxygen, O2. In the products, you always have CO2 and H2O. Now, of course, the water is vapor, right? It's not liquid, it's steam, because the temperature of the fire is a lot more than the evaporation temperature of the water. So a combustion is a chemical reaction, is exothermic, right? It gives off energy, whereas an endothermic reaction is one that requires energy. And a combustion is exothermic. It releases heat, so the reaction releases heat, and that's what warms up the environment. So it's an exothermic reaction. This is why it releases a lot of thermal energy. It releases light. Burning is a common type of combustion reaction, and usually, well, there's one combustion here, which we have propane gas. So that's the fuel. And then so you have your fuel, which is propane, and it reacts with oxygen, and it forms carbon dioxide and water. The only thing that changes in the combustion reaction is the fuel you're using. So you could be burning natural gas. Then instead of propane, C3H8, right, you'd have natural gas, which is CH4. That's the only thing that changes. The rest of the reaction remains the same, and it's going to balance differently. So the coefficients, when you balance the equation, coefficients will be different. But the reaction itself stays the same. So this is it. We looked at 5 different types of chemical reaction, 4 main reactions. The synthesis, where you have 2 elements forming a product. The decomposition, where you have one compound, one product that is separating into 2 elements. Then we have the single replacement or substitution reaction, when one element comes in and takes the place of another one in a compound. So a metal replaces a metal, non-metal replaces non-metal. And the last one was a double replacement reaction, which is when you have 2 compounds and there's a switch of partners in the 2. So the metal of one compound takes the place of the metal in the other compound, and that goes back into the first compound. So I'm going to invite you to look at this video, this one, and as a review for what you've just learned. And I hope that you see that chemical reactions, or at least these 4, 5 simple patterns, are easy to recognize, and you're going to use those. So remember the patterns, and you're going to use those to be able to predict the outcome of a chemical reaction. Because if you know what you start with, right, if it's 2 elements, then automatically you know, oh, this is going to be a synthesis, and the product is going to be the combination of those 2 elements. So you can predict what's going to happen because you know what you start with and you know the pattern. And that's what we're going to do in some exercises coming up. I can give you some reactants. I can give you the things that you start with, and look back at this video presentation, and you'll see all 4, all 5. It's always a different pattern you can recognize just by looking at the reactants. So thanks for watching, and have a great rest of your day. Thank you.